Okay, this next one has some more things going on with it. We have a fraction inside instead of a regular number. So how we're going to deal with that is we're going to put it into a different form before we start doing transformations. So first we're going to work with the equation itself, because in this it may not be a familiar form to us. So the 1/3, we're going to write that as 3 to the negative 1 power instead. So when I rewrite it, I'm going to put 3 to the negative 1 inside instead of 1/3, and then I have x minus 3 and then plus 1. The negative here, I'm going to multiply it by this, but I'm not going to go ahead and distribute that. Instead, what I'm going to do is write it this way. I'm going to put the negative outside the parentheses, and the only reason why I'm doing that is because now we see that since there's a negative in the exponent position, we know it's going to be a flip over the vertical axis. So that's why we're writing it and leaving it in that form. So let's start by doing each of these successive transformations until we get to the final answer. The first one we start with is always going to be our base graph, y equals 3 to the x. So that one, it's going to go through the point 0, 1 and kind of go up like that. So it looks real similar to the 3 to the x, the 2 to the x, 4 to the x. All those kind of look similar to that one there. So the main thing is it's got to go through the point 0, 1. Now, when we do transformations, we do them in order with order of operations. So we're going to begin with the exponent part. The plus 1 we'll do in the very last step. Let's first do this part inside parentheses. So I have, the one I'm going to do is y equals 3 to the x minus 3. Just that part. I'm not going to include the negative just yet. So if I have x minus 3, what that tells me is I have to move the graph 3 places to the right. So this point here at 0, that's going to also move 3 places over to the right, which means it's going to now be drawn right there. So over 3 up 1. So then the graph looks exactly the same. It's going to follow the y-axis, and x-axis in this case is still going to be your horizontal asymptote. So it follows that. It just got shifted over 3 places to the right. Next, let's apply the negative out front. So we're going to do y equals 3 to the negative x minus 3. That's the next one we're going to deal with. Now, the most common mistake I see with these is when students flip this, they somehow use the y-axis as a pivot point and the whole graph ends up over here on the left-hand side. That's not right. So the correct way of doing that is you're going to use this point as your pivot. So you never want to use the y-axis as your pivot. You want to use this point as your pivot. So therefore, you're going to still plot the same exact point. So it's still going to go through 3, 1 there. So instead, the graph now, just draw it in the opposite direction. So it's going to now go through here, and it's going to look like that. So again, don't use this as your pivot point. You're using this dot. That's your pivot. And we flip it over, and it's going to look like that. Okay. The last thing we're going to do is we'll apply, and this is where we're going to graph our final equation here. Now we're going to go ahead and add the plus 1 in on the end. Now the graph is going to look exactly the same as it does here, except we're just going to shift it up 1. Let's talk about what the horizontal asymptote would be before we draw that, because then it'll help us to know how to draw it. The 1 in the end here, that's always going to be your horizontal asymptote. So whatever number is after the exponent position, that's what you put in. Remember, when you do your horizontal asymptote, you do need to make sure you put the y equals in there, because it is an equation of a line. So we have y equals 1 there. And we can show that on our graph with a dotted line just like that. Now this point, that's going to move up 1 unit. So it's going to be over 3, and then it was at 1. We're going to move it up 1. So it's now going to go through 3, 2. So the point's going to go through there. The graph, though, is going to look exactly the same as before. So it's going to still come down here and kind of fall through that way. So this is what your final graph would look like. It's falling, it goes to that point there, and it follows our horizontal asymptote. Let's now do domain and range. Now your domain is talking about It's going to still use all the x values. Again, there's nothing that restricts that. We can put any x value in there we want. The range is talking about the y values the graph is using. For this, the lowest y value the graph uses is going to be 1. So I put 1 here, and it's going to be with a parenthesis because it's never actually going to reach 1. It'll get very close to it, but never cross that. And it's going to use all the values above it. So that would be your range 1 to infinity.